Good afternoon, everyone. I'll get people to start getting headphones on. I'll take my full minute of fame for this one as we let people in a little bit later today because all the headsets started to want to go home early. So in saying that, if your headset starts to flash red or turn off, just raise your hand. We've got people that'll come around. We've hopefully replaced a lot of them. I've already got a hand raised there, so that one's already giving up. Now, my name is Aaron Peterson. I'm a solution architect here at AWS. I've been here on stage 6 all day, and we've had an absolute ripper sessions, and it doesn't stop. I think we've left the absolute best to last. In saying that, when you do get to the end of the presentation, if you could provide us some feedback, Mithil's presentation today, if you loved it, we'd like to know about it, because if this is the content you'd like to hear about, then this is your way of telling us that for any future events. So this one is very topical. It's very bleeding edge. This is happening right now, and I will definitely be listening to this one as well to understand more about model context protocol and agentic AI. I'd like to welcome to the stage our AI ML specialist principal, Mithil. Mithil.
I'm sure you have all heard about AI a lot today, but this is another exciting topic. It's state of the art. I'm going to talk about model context protocol. I know a few of you are settling in, but if I can get a show of hands, how many of you have heard of model context protocol before? Wow, quite a few. So I'll get into some details as well. This is level 300, so I'll get into details. If you're not following some of the slides, that's fine. Just skip them. The presentation is discrete, so you should still be able to enjoy the rest of the show. So let me get started. I'm going to start with a definition of what is MCP. I'll cover why we need MCP. I'll talk about how we use MCP on AWS, and this will be a short section. I'll talk about some challenges and opportunities, especially as you take this into production. Show you a quick demo. Actually, I have 3 cool demos, and then give you some links so that you can get started. So without waiting too long, let me get into this. So what is model context protocol? Now, I'm sure you've all heard of AI, and you've all heard of RAG, which is retrieval augmented generation. This is how you can have your company information that AI agents can access. But if you want to go a step beyond that, can you get the AI agents or your generative AI application to start using some of the external systems that you have? So on the slide here, you see 3 external systems. You see AWS, Knowledge Base, GitHub. I'll take the example of GitHub. Let's say you want your generative AI system to be able to access GitHub. You want to find out how many open pull requests I have. If your AI application has to do that, it can do that via MCP. MCP has 2 things, 2 components. It has a server called an MCP server. This is where you write code. This is where you write logic that will be able to talk to the GitHub server. And then you have the client. The client is what your generative AI application will first use. And I'll explain how this flow works from end-to-end perspective. But the key takeaway here is that MCP is a protocol that allows your generative AI system, your smart agents, to be able to communicate with the external systems. So why is this popular now? It was introduced by Anthropic, and it is open source. The reason they introduced this was to solve the AI complexity problem. And I'll talk about that problem a bit later on as well. It is a client-server protocol. It is used to connect your generative AI application to the tools and data that you have within your system. The good thing is there are pre-built SDKs available out there, and there are also a lot of integrations available. So if you have external applications like Slack, for example, or Drive, you don't have to build your own integration pattern or your MCP server. The community has done that for you. And essentially, it has 3 parts, and I'm going to talk about the 3 parts. So MCP has 3 parts. Let's look at those. So the first part is resources. This is where your generative AI application can directly access data from the third-party application. So this allows servers to expose data, and the client then decides whether it wants to use the data or not. The second part is prompts. This is where the external application has prompt templates that you want your generative AI application to use. So the MCP server exposes the prompts, and your client uses it. But the most important component are the tools, and this is probably what you want to look at. So tools are what the MCP server exposes to your generative AI application. And I'm going to talk about how that flows and how the tools are being used. But this slide talks about just broadly the overall components. But let's take a step back. Why do we need MCP? So when this all started, when LLMs came into being, LLM is large language model for people who don't know. When LLMs came into being, they were able to call external tools and external functions. So you give them 10 different tools, and you give a query, and they can tell you that, look, this query can be solved by a particular tool. If you want the number of open pull requests, you can call a GitHub API. But then your code would have to actually call the API. The LLM doesn't do that for you. You will have to write code to make that function call. That's when the industry said, let's make it easier. Let's try and build agents now. So the agents do some of this functionality. The agents can call the function on your behalf now. So the LLM says, right, to find out the number of pull requests, you need to call a GitHub API. The agent then calls the API, and the application doesn't have to worry about it. But there's a problem with this. The problem is the agent now needs to understand about all the tools that GitHub has. It has to understand about all the tools that the AWS SDK would have, your Slack would have. And that's quite a lot. That's why the industry said, let's separate that out. Let's put all the tools inside an MCP server. So this is kind of the next generation. This is where you're saying all these external systems will have their own MCP servers. And this MCP servers will have the list of tools that your application can call. Now, when your application wants to call a tool, wants to find out how many open requests I have, directs this request to the MCP client, then server talks to GitHub information. So I'll explain how that flow works from an AWS perspective. But this is generic. So let's talk about a generic request flow. And this is sequence diagram for architects in the room. They would love this. If you are a business owner, you might not appreciate what this is, but this is pretty cool. Trust me, we live by this. So what you see here are the 5 actors that you have at the top. The first step is where the host, this is your generative AI application, could be a chatbot. When it starts, it will find out what are the tools available. So let's say you have 5 MCP servers that are registered, servers that can talk to Slack, to GitHub, to Drive. All of this will have tools that are available. The host will find out what are the tools available. When the user fires a query, I want to know what is my AWS bill. The query goes to the appropriate tool. So the LLM says, I know how to find out the AWS cost. Just call the AWS API. And then this goes to the MCP server. The MCP server says, yeah, I know how to call the API, and it does the actual call. And then the response goes back to the user. So this is kind of how the end-to-end flow works. The way and the next 3 slides are how you implement this on AWS. Now, this is an ever-changing field. By the time you go back and you start implementing, this might have changed. So take this as the current way to do this. It will evolve in the next few months. So current way to do this is what we call inline agents. And now for those of you, has anyone used Amazon Bedrock before? Oh, quite a few. So if you've used Amazon Bedrock before, Amazon Bedrock has a thing called Bedrock agents. And they have something called an inline agent. I won't go into the details, but essentially you can use inline agents to make an MCP call. The way it works is the inline agent would give the control back to the application, and then the application calls the MCP server. Again, you don't have to. I'll probably explain in the next couple of slides. If you have used Bedrock agents before, the way it works is a user fires a query, goes to a Bedrock agent. The Bedrock agent invokes what we call an action group, so essentially a Lambda, that can query your external system, get the response back. This is how it's traditionally worked. But with the new MCP world, the way it works is a user sends a query. to Bedrock agent. The Bedrock agent says, this cannot be solved by me. This needs an external MCP server. I'm going to give the response back to the user. Now, if you think about this, this is going back to the original function calling. But in this case, we have got an SDK that talks to the MCP server on your behalf. So the SDK calls the MCP server, which gets the external information, gives you the data back. So without getting into details, the key takeaway is now we have got a separate MCP server that understands how to call external functions. And your inline agent has an understanding of that MCP server and uses that to accomplish that task. At the end, I'm going to show you demos which makes all of this real. I'll show you real examples of how people are using this for the use case. Now, AWS has a service called Amazon Q and Q Developer. Q Developer is a coding assistant. Amazon also has a CLI, which you know about. Now, you can use Q Developer within a CLI. The reason I'm bringing this up is because now the Q CLI can also talk to MCP servers. And this is very powerful. Imagine sitting at your laptop, opening a terminal, and being able to talk to multiple external systems. You can open the terminal and ask it to find your AWS cost, find Opal GitHub request, create a new pull request, and so on. So before MCP was available, you had the CLI, which was able to call bash scripts, just external scripts. But with MCP, now there is a standard way to access external tools. And this makes it extremely powerful. If you're a developer, and this is mainly for developers or builders, you now have access to all the external tools right within your terminal window. And I'll show you an example of this in action as well. Of course, this is all well and good when you talk about conceptually. But now when the rubber hits the road, when you want to get this into production, what are the challenges that people are facing, and what are the opportunities that MCP presents? Let's start talking about opportunities. And it starts with the fact that generative AI application integrating that with external system is an M by N integration problem. What that means is, let's say you want to build 5 chatbots, and you have got 10 external systems, which means you have got 5 into 10, which is 50 different integration points. That's challenging. You don't want to write 50 different integration codes. That's what MCP does for you. What MCP does is simplifies that integration pattern into an M plus N pattern. So think of MCP as USB for AI application, where you can plug in your devices or applications on one side. So it transforms the M by N into an M plus N problem, which is you have to think about the 5 chat applications and the 10 MCP servers that you're going to pre-use. You get a consistent implementation because all your applications are using MCP servers. And this, of course, reduces development and maintenance time. The key here is, though, that this has a lot of support from the industry. And I guess that's one of the reasons you are all here, is because you have heard this everywhere, and everyone is adopting it. And major players like Anthropic, us, AWS, OpenAI, everyone's adopting this. So this is a lot of people are betting on. And in addition to that, there is also a huge community support behind this. A lot of these MCP servers have been built by the community already. So you don't have to build them yourselves. You can use them off the shelf. So you can directly download from GitHub and start using them. Talk about MCP. I explained that earlier I said you have your application, you have a client, you have a server, and then you have the third party. Now the client needs to talk to server. And how will the client talk to server? Does the client have to be close to the server? Can they be separate? How do you host the MCP servers that the rest of your organization can use that? So I'll answer some of those questions here. First pattern is, and the first form of transport is standard I/O, which is what you would have seen when you see examples of MCP out there. When you see MCP being used in desktop, for example, you have the client and server running in the same machine. So they communicate via standard input-output. This is good for desktop, but this doesn't scale. You can't use this for production because in production, you want MCP servers to be hosted somewhere, maybe in your EKS cluster, your Kubernetes cluster. That's why the industry has now come up, and this was, in the last month, this was finalized. So now the community has finalized HTTP as the second protocol that you can use. And talk to the server on HTTP. Now, different ways that it supports. It supports GET, POST, and server-side events, which is continuous chatting. But the key takeaway here is now, from an enterprise level, if you want to start implementing MCP servers in a central place, you can put them maybe in a Kubernetes cluster, or maybe just on simple machines somewhere, expose them via an HTTP API, and your clients can be anywhere. It can be your web application, it could be your desktop application, and they talk to each other using HTTP. When I talk to customers, next question that comes up with, and I'm sure you're all thinking about this, is what about security though? Does the client authorize with the server? How does the user, if I'm a user, if I have access to GitHub and Slack, Drive, how do I make sure that I'm authorized to all three of those separately? And that's where the community has come up with OAuth 2 as the authorization format. So OAuth 2.1 is used as the format for authorization. So the way it works is, let's say I open up my terminal and I want to start using GitHub. I ask a question. The question goes to the MCP server. The MCP server says, oh, but I don't know who you are. I need you to be authorized. So it will open a pop-up where I put in my GitHub credentials. It will store the token, and then it will send me another token so that I can use that for the rest of the authorization flow. So just rephrasing this in a single line, OAuth 2.1 makes it easy for your GenAI application to authorize to multiple third-party applications. Now, it's not as simple as I've made it sound. The complication arises because now we have got multiple tokens, multiple OAuth tokens that you have to take care of. And we'll talk about some of the security concerns that brings up as well. If there's a non-human client, then you can still use OAuth 2.1 with dynamic client registration, which we don't have to go into details today. And this authorization can be part of MCP server or separate. The reason this is important is because now you can have a separate layer for authorization. So all your MCP servers can be behind a separate layer of authorization. So before I go into the demos, just a very quick overview of some of the security risks this brings. Now, I do realize I'm not going to be able to tell you about all the mitigation plans for all these issues, but it's good to understand what some of these issues are. And some of them do have a mitigation plan. So the first is, can you trust the external MCP server? Now, we have said that some of these servers come from unofficial repositories, from open source. So how much can you trust them? Are they scanned for vulnerabilities? Can someone do a prompt injection and get the information out? Some of the servers can also be malicious. You download the third-party servers, but it does something else and then hacks your system. And there's consent fatigue, which is where every time an end user is using a GenAI application, which is using an MCP, user will have to say, I'm OK that you use this tool, which is what is called consent. That is, yes, OK, use this tool. Yes, go to GitHub. But sometimes people would get fatigued with this. They'll keep on saying yes without being able to understand or read the whole thing. So that's the risk. Second is runtime security risk. Again, this is straightforward, but think about risk when a token from one MCP server is accidentally linked to another MCP server, or when people write MCP server without adequate authentication. And third is, and this is more of an issue when you have a STDR kind of, when you have a server in the same process, which is where sometimes you have credentials stored as text files. Now, this issue has kind of been taken care of by the new OAuth 2 protocol, but it's still there if you're using it locally. And of course, I've seen MCP servers where there's no authentication at all. This is a big red flag. All right, now the cool part. I'm going to show you 3 demos. And these 3 demos have 3 different use cases. I'll walk you through the use cases as I'm showing you the demo. So the first demo is when an external, now I won't explain what the technology is, but from a user point of view, a user is trying to find information from a financial filing from Amazon. So the question that the user is asking, how many physical centers does Amazon have? The information comes from a document. The document has been stored in a knowledge base somewhere, and my agent has been connected to an MCP server that has access to that knowledge base. So quick demo, I start the application. This is a user interface for Bedrock. And I'm asking a question based on the knowledge base ID. So this is a knowledge base that I've stored my document in. Can you tell me how many facilities does Amazon have? Now, if you see, I've said do not re-rank results. The reason I put this in is because the LLM also is able to pass parameters to this tool. So if you're thinking I've got methods which have parameters, you can pass them as well. And I got a response from that document saying that we've got so many different facilities. So this example shows how we can use external knowledge base from an MCP server as well. And what you see here is how I've configured different MCP servers with this particular client. So I can keep on adding here. I can add GitHub or Slack or whatnot. And now all of this will be available to my application. The second example I'm going to show you, and this is a pretty cool example, because here the application does three things. It is able to connect to an external system via an MCP server to find AWS cost. It is also able to write some code. And we'll see how that works. So the question I ask is, what are the AWS services where I spent most in the last 7 days? And create a bar graph for me as well. This is interesting. I'm asking it to create a bar graph. So think of this as your external application. I won't put a UI because I wanted you to get an inside feel of this. So the first thing you see is that now your external application has got tools that it can access. So the first thing, and if you can see here in the purple, it called the external tool, but there was an error. So it can debug itself as well. So it is trying to fix the error as it is going. And as you see, it's found the cost. So it has gone to my AWS account using the MCP server. It has got the total cost, total usage that I've made for that MCP server, for my account. And then it is now going to create a bar graph from this. Now, the way it is creating a bar graph, it is actually writing Python code to create a bar graph. So it writes Python code, runs that in a sandbox environment, and then it is able to come up with the final cost. It is able to come up with a graph for my AWS cost usage. So you should see a file pretty soon that shows the graph. So this example shows three things. First is we can call an external system. Second is how we can write code. And third is how we can store files locally as well. All of this is done by an agent. So imagine as a developer, we did this ourselves, but now an agent is doing all three of us for us. And the last demo that I want to show is, and again, this is one of my favorite demos. This is where you have an AWS CLI that has access to certain tools in the web. Now, the question I ask is this. I want to build a 3-tier web application, and I have got 10 users, and I've got 100 gigs of data. How much is it going to cost? I think all of us has faced this question before, and then we have had to prepare a cost report before we embark on a project. I asked this generative application to do this for me using AWS CLI. Let's see how it does it. So I start a chat interface. So this is a chat interface for Q CLI. As you can see, I've registered 2 MCP servers here. The 2 servers, one of them can get me the latest pricing from the web. So as you can see, the first server is cost analysis MCP server. So this gets me the latest AWS pricing from the web. Now I'm going to ask the question, which I talked about. So next I'll paste the question, which is I want to build a 3-tier web application. I'm giving it some details, but I'm vague. I haven't told it how much Lambda costs or how much cost or EC2 cost. I want it to go to the web, to the pricing page, find out the latest price for the particular service, come up with a sample architecture, assign cost to each of the services, and then come up with the final cost. If you see here, it is also asking me, should I use this tool? And it is going to ask me every time, which is where the consent fatigue comes in, which is where I'll say, just do it. I have no patience left anymore, just do it. So now it's going to the web, finding price for API gateway, for Lambda. And it is also thinking. It is thinking right now about an architecture. It is thinking about how we can assign that cost to that particular architecture. So in the last bit here, it is now completed. It's all the calls. Now it is going to come up with the architecture. So as you can see here, it has come up with a sample architecture on its own. And it is also coming up with detailed cost analysis. At the end of this, it should be able to give me one number, which is the cost for the 3-tier application that I want to build. So the green box here, that's the actual cost. So just shows the power of MCP. These are very simple examples, but the reason I chose them is because you can extend this to any of your external systems. So I've seen customers start thinking of, how can I combine different systems that are behind my microservices now using agentic workflow? How can I have two organizations talk to each other and exchange data using MCP? So the possibilities are immense. What you saw here is just a tip of iceberg. The community is working on standards that will make it easy. That will make it easy for other organizations to adopt it. And you'll see a lot of new changes coming in the next few months. If you're keen, to replicate some of what you saw here today, some of this QR code will help. And you're always welcome to reach out to us when you get a chance. So that's me. Thank you so much. Thank you for staying back. Really appreciate your time.